This video will look at the PMT function in Excel, which we use anytime we're talking about a loan payoff. Now your book has a formula that's by hand that you could use, but it's much nastier and it will take way more time. So it's better to learn how to use this PMT function in Excel and make all of the problems in Connect and on your lab book homework so much quicker. So the PMT function is very similar to the FV function. It has a lot of the same inputs. It's got the APR interest rate, the N, which is the number of times a year you make a payment or you're paid interest, and then Y is time in years, and then P is principal. It looks a little bit different with the inputs. It doesn't have a PMT input like a monthly payment to a savings account like the FV function did. Instead, this function tells us how much you will pay per month on the loan. And again, we will give you the formula just like it's written here at the top of the video on your test paper. You've got to be able to go from this formula to putting it into Excel and then using it to solve problems. So just like with FV, we're going to make a chart labeling the inputs exactly as they appear. So APR, then N, then Y, then P. And this is going to be the PMT function, which we use to get our payment on a loan. So to put in this function, it'll be equals PMT, parenthesis, APR divided by N, comma, N times Y, comma, negative P. And again, that negative sign is probably the most commonly missed thing. If there's a typo, it's probably because you forgot a negative sign. So we put those in, and currently it's not happy, but that's okay because we haven't put any numbers in yet. So it says Sue borrows money to buy a car. She puts $8,000, so that's the principal of the loan, on a 4-year loan with 3.7% interest that's compounded monthly, or meaning she'll make monthly payments. So what is her monthly payment? Well, just plugging all these things in, we see that her monthly payment is $179.56. So it says, how much does she pay to pay off the loan? Well, she's paying $179.56. She's paying that 12 times a year, every month, and then she's doing that for 4 years. So her total payoff will be her monthly payment amount times the number of months per year times the number of years, or it's going to take her $8,618.90 to pay off the loan. This is her payoff amount. So we want to know, how much did she pay in interest? Well, interest will just be the difference between how much she has to pay off and the principal of the loan. So she paid $8,618.90 to get rid of it. She borrowed an initial principal of $800. So this loan cost her $618.90 in interest. So that's a good chunk of change. $600 is a lot of money, but a lot of people would probably consider that it's probably worth paying $600 for interest so you can go ahead and have this car. Maybe she needs it to get to work or to chauffeur her kids around or whatever it is. But Sue made the decision to borrow the money, so she'll have to pay $600.18 or $618.90 in interest. Right, another example with Jack. So this time Jack is borrowing $30,000 to pay for school. He has a 15-year student loan at 2.3% interest compounded monthly. So let's put in our values. So APR, N, Y, P, and then we're going to calculate our monthly payment, that PMT function. So we do equals PMT, parenthesis, APR divided by N, comma, N times Y, comma, negative P, close parenthesis. So it says if Jack pays the loan off on schedule, what is his monthly payment? So let's see, we have a 2.3% loan. He's paying it monthly. It's a 15-year loan, and he borrowed $30,000. So Jack's monthly payment is going to be $197.22 on this student loan. So to get his total paid, or his payoff, however you want to say it, his total paid will be the fact he puts $197.22 on the loan. He does that 12 times a year for 15 years. So if we multiply his monthly payment times 12 times 15, we see that it costs him $35,500.43 to pay off the loan. So his interest will be the total amount he had to pay to get rid of the loan minus what he initially borrowed, which was $30,000. So he paid $5,500.43 in interest. All right, so it says Jack wants to pay off the loan faster. I'm going to drag my equation over so I have a new place to work. I don't want to lose my first answer. So it says he pays $500 a month now. How long will it take him to pay off the loan? So it's asking us how long. That means we're going to be solving for y. This is going to be a goal seek problem. So we can assume everything else is the same, 2.3% interest, paid monthly. He's borrowing $30,000. Why is Excel not happy? Problem with the formula. It's not telling me anything. Let's just see if nothing's sticking out. All right, so sometimes if it gets fussy on you, sometimes what it wants you to do is take a guess for that missing value. So I'm just going to put 10. There we go, and now it's working. So if Excel ever gives you something funny and you know that you're trying to do a goal seek, just put an initial guess in there, and then usually that'll solve it. So when I didn't have a Y, it was giving me an error. I just put some number in there. Again, it doesn't matter. I just put 10. And now it's giving me a number, and now I'll be able to goal seek. But if it's doing that pound sign number, it's not going to let you goal seek. So again, I just stuck a number in to make Excel happy, and now we can goal seek and get to the answer we want. So now the payment's going to be $500. We want to see how long it will take. So I'll go to Data, What If Analysis, Goal Seek. The monthly payment is now going to be $500, and we're going to get to it by changing the time that it takes. So he will be able to pay off this loan in 5.32 years, rounding to 2 decimal places, rather than 15 years if he pays $500 a month. So it says, how much will he save by paying the loan off early? Well, his total payoff is going to be the $500 times 12 months a year times the time, which is that 5.32 years. So he's going to pay $31,900.35 to get rid of the loan. So the interest that he's going to pay is that payoff amount minus the $30,000 that he borrowed. So he's only going to pay $1,900.35 in interest. So his savings by paying it off early is going to be what he would have paid in interest minus what he ended up paying in interest. So he's saving $3,600.08 by paying $500 a month. So you may think, yeah, wow, $500 a month, that's a lot, but it pays off this loan so much quicker, and it ends up saving him $3,600, which I think a lot of people would agree is a good chunk of change to save.